This video will follow along with the Chapter 1 notes from your textbook. So in Chapter 1, we're going to look at statistics, the art and science of learning from data. So when you first entered this course or first signed up, you probably wondered, why do I need a statistics course? Why is it important as a part of general education that you take a statistics course? And part of the reason is that as a society, the amount of data that we've produced or are producing is increasing at a rapid rate. And so whether you realize it or not, decisions that impact your everyday life are being made based on the analysis of data. So it's important that everyone has at least a basic understanding of how data is analyzed and the implications that has, so that when you are presented with results, you can critically think about those results and be able to say something. And so here's a quote from H.G. Wells that I think kind of summarizes this. Statistical thinking will one day be as necessary for efficient citizenship as the ability to read or write. And I really do think that this is true. We could passively go through our lives with no knowledge of statistics, but I think knowing a little bit about statistics is going to make you a better consumer in your everyday life as well as your professional life. And so this is one thing that I often hear students say, but in my field, I'm never going to use statistics. And so this is a misconception that I would like to kind of dispel, because whether you realize it or not, there are very few fields out there that don't use statistics. And so as an example, anybody that goes into, let's say, some kind of field involving medicine, whether it be nursing or physical therapy, being a doctor, any of those, you're really relying on the statistical analysis that others have made when it comes to regard as to medications, different therapies, things like that, when you're trying to decide what's best for a patient. And so having an understanding of how those decisions are made will help you make better decisions on what you would do with one of your patients. And there are many other examples from other fields of how statistics comes into play. And so one place that you're going to see this in your everyday life where this is going to become really useful is in social media. So anymore when it comes to whether you're on Facebook or Twitter or Instagram, a lot of times we're bombarded with either different types of plots or graphs, news articles claiming certain things like if you drink coffee, you're more likely to develop cancer, or if you drink coffee, you're not more likely to develop cancer. And so we're kind of bombarded by all of these claims on a regular basis. And so part of the goal of this course is to kind of help you detangle all of that information so that you can become a good consumer when you're faced with these things on social media or anywhere else online. And so another misconception that students often think of, well, statistics is just math, right? All we're going to do is work with numbers and equations. And that's really couldn't be further from the truth. Yes, we're going to use math in this course, but more importantly, statistics is more about concepts and ideas and how things relate to one another. And so as we move through the course, I really want you to kind of, keep that in mind, that we're not just focused on the numbers, we're really focused on the language and what it is that we can learn from data. And so there's a website down on the bottom of page 1 of your notes, and I do encourage you to visit that website and to kind of look at, it's a discussion of why learning statistics is important, and not just for math majors, but many other fields as well, to kind of help you understand of why a statistics course is usually included in a general education degree. And so again, don't think of statistics as just being a bunch of numbers on the board. It really is much more than that. It's going to be about concepts and ideas. So again, there are the ideas. So for example, let's look at this news article here. And so this news article is also located in your notes, and you'll notice it's from May of last year. And so it says President Donald Trump's approval ratings is holding steady in a new CNN poll conducted, but his numbers on handling several key issues are climbing as almost 6 in 10 say things in the country are going well. Overall, 41% approve of the president's work and 53% disapprove. Those numbers are about the same as the end of March. On the issues, however, Trump's numbers are climbing. Approval is up 4 points on the economy to 52%, and the first time it topped 50% since March 2017. And it goes on to give you some other numbers. So most likely, you've probably already seen articles similar to this. And so one of the goals for this course is for you to become a critical consumer of information. And so we want you to be able to answer things like, well, where do these values in this news article actually come from? How reliable are those values? And what reasonable conclusions can be reached based on them? And hopefully, many of you have seen news articles like this, but what happens is most people just kind of take them at face value and don't think further. And so this course is designed to help you do just that. When you present it with information, to critically think about it. And so we're going to start out with some of our first definitions. So the first one here is data. That's going to be information we gather with experiments and surveys is collectively called data. Whereas statistics, on the other hand, is the art and science of designing studies and analyzing the data that those studies produce. So statistics, this field is all about taking data and summarizing it and learning from it. And so that's why I was saying, it's not just going to be the numbers, but it's also going to be the concepts and the ideas that go along with that. So statistical problems are going to investigate a process that involves 4 components. One is going to be able to form a statistical question. Once you have that question, you'll go out and collect data. Then you're going to analyze that data and then interpret the results. So in this section, we're going to introduce 2 new vocabulary words, and these are probably some of the most important vocabulary words you will learn this entire term. And so these 2 words are going to be sample and population. And then along with sample and population, we're also going to learn what's known as parameter and statistic. So those 4 words together we're going to use throughout the course, so you're going to want to make sure to go ahead and take the time and familiarize yourself with them now. So again, here are these important definitions, and I'll give you just a moment if you want to pause the video at this point, take the time to read through these 5, and then once you've read through them, we're going to go through an example to illustrate the difference between these different definitions. And so here is the example. And so the example says, suppose that I'm an ant. And yes, I said ant, not aunt. And as a matter of fact, I'm queen ant. Lately, I've noticed that my worker ants have been acting somewhat discontent with their jobs. I decide that I want to find out about job satisfaction in my hill. There are so many ants in my hill that it would be impossible for me to ask all of them if they are discontent. So instead, I ask 200 ants how they feel. I find that 99% of them are dissatisfied and would prefer to spend their time eating at the picnic rather than carrying the food back to me. All right, so we've got this example, and so now let's kind of pick through the different parts and identify each of those definitions that were on the previous page. So first definition we have there is subjects. And so the subject, those are going to be the entities that we measure in the study. So notice here the entities here that we're going to really be interested in, those are each of those ants that live in the anthill. Further, the group that I want to learn about or I'm examining here, that's going to, again, be all of the ants. So all of the ants here are going to be my population. So you can think of the population as always being the group that you want to learn about. Who is it ideally you would like to collect data from? Now, usually we don't get to talk to everyone or collect data from everyone. So instead, we only look at a small piece of the population, and that's what we call the sample. So in this case, since we spoke with the 200 ants to see how they feel, the 200 ants are going to be my sample. Now, as far as the parameter and the statistic are concerned, notice that parameter and population both start with the letter P. So the parameter is going to be that specific piece of information we'd like to learn about the population. So in this case, the parameter would be the percentage of all of the ants living in the anthill that are currently dissatisfied. Now notice I can't attach a numeric value to that, and the reason for that is I was unable to speak to all of the ants, so I can only say what the parameter is in words in this case. On the other hand, I was able to speak to the 200 ants. So the statistic is going to be an estimate of that piece of information I want to know, but applied to the sample. So in this particular case, since 99% of the sample were dissatisfied, that tells me that my statistic is the 99% of those 200 surveyed that are dissatisfied. So notice next in your notes, you've got some examples. And so you've got example A and you've got example B. So take a moment, pause the video, and see if you can find the answer to example A. And then after you pause the video, we'll go through the answers together. All right, so notice for example A, we wanted to know how American voters will vote in the next upcoming election. So notice that the group that I'm truly interested in learning about are all American voters. So that tells me that my population here is American voters. Now I didn't get to speak to all American voters, I only got to speak to the 550 respondents. So those 550 that I actually get to look at or examine, that constitutes my sample. So my sample here are the 550 respondents. Now remember that the parameter is always going to be that value that comes from the population. So here I'm interested in the percentage of all those Americans that are going to vote Republican. So that is my parameter. And notice I cannot attach a numeric value here because I didn't get to talk to all American voters. On the other hand, the statistic, that's what comes from the sample. So of those 55 respondents, I was able to find that 52% of them are going to vote Republican. So the 52% is the percentage of the respondents that will vote Republican, and that is my statistic. So here's another example. So again, take a moment, pause the video here, and then we'll look at the answer together. So notice in this case, we were interested in all of the residents living in Madison County. So that's why my population here is all of the residents. Now I was only able to speak with residents living in the zip code of 40385, so that's why my sample is going to be those residents. The parameter in this case is the percent of all Madison County residents who recycle, and that's because that's the piece of the piece of information that I would like to know about the population. On the other hand, the statistic is going to be that information, but from the sample. So of the sample, I know that 74% of them will recycle. And so that's why the statistic is the 74% is the percentage of the sampled residents from zip code 40385 that will recycle. Now in your notes, you'll notice there are two extra practice problems, C and D. So if you take the time, go ahead and work through those. And then at the bottom of page 4, you'll notice the solutions for each of those practice problems. So next in your note, we've got a couple critical thinking questions. They're on A and B. So if you'd like to, take a moment and pause the video. See if you can jot down some ideas for A and B, and then we'll talk about them together. All right, so let's talk about these two questions. So the first thing we're going to do is we're going to give 2 reasons why taking a sample is necessary. So one reason that taking a sample might be necessary is time and money. So I guess those are really 2 reasons, but you can imagine if I were interested in everyone that lived in the United States, it would take a lot of time and a lot of money for me to be able to go and interview everyone or to collect data from everyone. So and that's a case where if your resources are limited, you might not be able to go and examine an entire population, but you might be able to go to speak to a sample instead. So instead of maybe speaking to everyone that lives in the United States, I might speak to 200 people. And 200 people will be much more feasible. Another reason that taking a sample is necessary is sometimes the sampling process itself can be rather destructive. So maybe I want to test the safety of new cars. Well, in order for me to test the safety of an entire population of cars, maybe part of the process is for me to crash those cars. Well, you can imagine if I crashed all of the cars to test their safety, I wouldn't have any cars left to left to sell. So instead, I might take a sample of 20 cars, put them through the crash test, and then use that sample of those 20 cars to help me learn about overall if all of the cars are safe. And now for B, it says ideally when we pick a sample, we want it to reflect the characteristics of the population. Do you think a sample will always have characteristics that are similar to the population? Well, the answer here is no. There's lots of ways that we could choose samples, and sometimes we choose them for convenience purposes, but when we do that, we don't end up with a very good sample. So, for example, what we might happen is, let's say I wanted to learn about all of the students taking classes at EKU, and so maybe I go to the dining hall to talk to some students, and I just talk to whoever walks by. Well, if I do that, I would be missing any students that are only online, and so I wouldn't get any feedback from them, and I might be missing an important part of the population there. So in that case, my sample wouldn't be very representative of the population of all EKU students. And so as we move forward in the course, we are going to talk about how sampling plays an important role, and how we sample is going to tell us whether or not the conclusions we have are valid. So we've got two more definitions here. There are descriptive statistics and statistical inference. So descriptive statistics refer to the methods for summarizing the collected data. So that's going to be purely only describing the data that you have at hand, whereas statistical inference is going to be using the process, or probably is the process, of using the information contained in a sample to draw conclusions about what's happening in a population. So when we have statistical inference at play, you can look for words like margin of error and statistical significance. So take just a moment and read this news article or excerpt from a news article, and it's also given in your notes. And then we're going to see if we can identify a descriptive aspect and an inferential aspect. So let's first look at a descriptive aspect of this article. So have a look at this sentence here. Notice it says the reduced proportion of plastic bags in marine litter was found from 2010 onwards. There was a drop of around 30% from the pre-2010 period compared with afterwards. So notice here they're talking about the data they have at hand. That drop of about 30%, that comes directly from the data they have at hand, and they're just describing it. So this would be a descriptive statistics. However, at the bottom, where it says, however, statistically significant trends were found for fishing debris such as nets and lines, the researchers suggest that better training and action by the industry could help reduce the amount of fishing-related items found on the sea bottom. So that word statistically significant, that indicates to us that we are working with inferential procedures here. In other words, we're taking the information that we found and we're extending it to say something even bigger. So that would be an example of inferential. So as we move forward, I want you to remember that one of your goals for this course is to critically think about the information that's presented to you. We're going to learn how to describe and analyze data so that you can critique the conclusions which are presented by others.